All right, let's go ahead and get started. Welcome to our webinar today. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we are going to discuss how to conduct and write your power analysis. So I'm going to go through the entire presentation first, and if we have any questions, I will do a question and answer session at the end. So feel free to type your questions into the chat box or the question and answer box, and we will go through those together at the end of the session. Should mention that we're going to send everyone a recording of this as well. So you can take notes, but you're going to receive a recording most likely tomorrow morning. So you can take a look at the recording, rewind, fast forward, and go through different points that you want to review. Okay. So I'll start out by giving a brief overview of the services that our company Statistics Solutions provides. We'll then dive into today's topic and discuss power analyses, when to use them, why to use them. And then I'll give a demonstration in both Intellectus statistics, which is our company software. You can run a power analysis in that software, and I'll also show you how to run a power analysis in GPower. GPower is a very popular software used today, especially requested by universities today. Many committees like to see a screenshot of how you calculated your minimum sample size. I'll show you how to do that as well. And then we'll conclude with a summary and the question and answer session. My colleague Isades is here as well, and she will be assisting with any questions that you have during the presentation. So if you have any questions about the services that we can provide, or if you need hyperlinks, Isades will be assisting with that. Our company Statistics Solutions provides assistance with every part of the dissertation journey and the dissertation process. So we start with topic development and go all the way to the end with the discussion chapter and preparation for defense. So the way our company works is we will assign a methodologist to you and we'll assign a literature review specialist. We have methodologists that are specialized in both quantitative and qualitative studies. So if you need help framing your research questions and hypotheses, developing your theoretical framework, narrowing down your purpose statement or your problem statement, figuring out what analyses you need to run to address your questions, we can certainly help guide you in that direction. So let us know if you need any assistance. We have a phone number at the bottom here, 727-442-4290. You can schedule a free consultation in which you will discuss with Janine where you need assistance, where have you hit a roadblock, and we can help guide you in the right direction. So our topic today is about power analyses. And first we need to lay the foundation. Why is the sample size so important for statistics and for quantitative research? The ability to find statistically significant results is highly contingent on your sample size. Essentially, the higher or larger your sample size, the greater chance you're going to find significant results. And the opposite is true as well. The lower your sample size is, the lower the chance is of obtaining significant results. Therefore, when you increase your sample size, you're also increasing the sensitivity of your statistical analysis, meaning you're more likely to find a significant result. If you don't have a large enough sample size, then important effects and statistical differences or relationships may go undetected. So it's important to find what that minimum sample size is. But at the same time, you don't want to aim too high. Many times when you deal with archival data, you could be dealing with hundreds of thousands, if not millions of cases. And if that is the case and you have millions of participants, you're going to find unanimous significance, which is going to cloud your results potentially. And this table here is an example of that. Significance is typically identified if your p-value is below 0.05. And we can see down this column here that every single result, almost every single result, is highly significant at the 0.001 level. That happens when you have a large sample size like this. 380,000 participants are being included on this logistic regression. So you have to interpret with a grain of salt. You don't want too many participants, otherwise everything's going to be significant. And you don't want too small of a sample size, otherwise you might not find significant results. So we need to find the sweet spot in the middle that is going to generate the best statistical result. What is statistical power? Statistical power is the probability of finding a significant effect if the effect actually exists amongst your population. So the power is calculated through this formula. It's 1 minus your type 2 error rate. And the type 2 error is essentially the probability of failing to detect an effect that actually exists. This is also called a false positive, a false negative. So failing to detect an effect that actually exists. That's a false negative, and that's type 2 power. Then we have, typically in the social sciences and psychology fields today, even business, the standard for statistical power is 0.8. You'll see that used a lot in research today. And power is one of the inputs that you include when you do a power analysis, which I'll show you shortly. So this 0.8 is really a percentage. If you move the decimal over right twice, this is 80%. So essentially, we want to have an 80% chance, at least, of finding statistical significance if the effect or difference does, in fact, exist. So what is a power analysis? A power analysis is an objective way of determining or calculating the appropriate sample size for your analysis. And when you do a power analysis, there are several inputs that you need to include. One being the type of analysis that you've proposed. So maybe you're at the methodology phase now, and you've developed your research questions, and you know that you want to run correlations, or maybe you know that you want to run t-tests. You need to know what analysis is going to be conducted in order to run your power analysis. So we have then the expected or hypothesized effect size. So you have to anticipate how strong of a relationship you are going to detect. And 99% of the time, you're going to see a significance level of 0.05. And then the power, as we discussed in the previous slide, is 0.8 conventionally. There are both a priori power analyses and there are post hoc power analyses. So an a priori is used in the methodology phase when you're trying to figure out your minimum sample size. A post hoc power analysis is done after you've collected your data and you've run your results and you're trying to figure out whether the power of your test is sufficient. So you're working backwards, you have the results, you have your sample size, you want to figure out whether you have a strong test or not. So that's a post hoc power analysis. There are software packages available that are free for conducting power analyses. I'll share a link with you. So we have G-Power, which is what we'll use today. And I'm also going to show you Intellectus Statistics, which is our company software. You can also conduct power analyses in there. Here are some hyperlinks to run power analyses. The first one is going to take you to G-Power. So the first hyperlink takes you here. And if you scroll down a little bit to this download section, you'll see a download link for G-Power. Windows, and there's one for Mac as well. So it's a free software. And the second link that I provided is the GPower manual. It's this link here, and it goes in depth through examples and how to run power analyses in GPower. You don't need to go through this whole thing, but maybe find the analysis that you're trying to run, and then just do a Control F and say we're looking for correlations. And then you can see right here, there's a table of contents. We're doing a point by serial correlation. I can click this link. Or if you're trying to do an ANOVA right here, differences in groups, you can click this link right here, and it gives you examples. Okay. And then our alternative is using Intellectus statistics, which I'll show you in just a second. Okay, so let's go through some examples. First, I'll show you GPower. So this is what GPower looks like after you download it. And it looks like there's a ton of inputs you have to include. It looks complicated, but it's really not. You just need to know what analysis you're running first. So say we're running a t-test. We're looking for differences between two groups. Are there differences in job satisfaction between males and females? You would do a t-test in this example because you have two distinct and discrete groups, males and females. So we go to the t-test family, and then we will select differences between two independent means, two groups here. Now we need to select how many tails is our test going to have. The number of tails is dependent on your hypotheses. So if you hypothesize that there's going to be a difference between males and females in general, we're not saying that males are going to score higher or that females are going to score higher. We're just anticipating a difference. That's when you do a two-tail test. And that is done most of the time. However, if you are hypothesizing in chapter 3 or in your methodology that one group is specifically going to score higher than the other, then you do a one-tail test. I'll show you both here. So the other inputs, we have effect size. And if you hover your mouse over this box, it will tell you the conventions for effect size. You can have a small, medium, or large. And the specific values, you can see 0.2 is small, 0.5 medium, and 0.8 is large. If you don't have literature in your topic to tell you what is the effect size I should use, just go with a medium effect size, which is 0.5 in this case. However, if you do have literature, and this often happens in medical papers, there is prior research to suggest using either a small or large effect size, in which case you'll then just substitute that value here. You'll put a small or large effect size. But most of the time, we don't have this literature. It's usually a new topic, so you go with a medium effect size. The next value is the alpha. So this is our level of significance. What p-value do we need to have to be significant? 0.05 is usually used there. We discussed during the presentation about changing power to 0.8, so I'm going to do that here. The default number in here is 0.95, but you'll want to change that to 0.8 manually. And then allocation ratio, I always just keep that at 1. So if I click calculate, you can see on the right side here, we can see the total sample size is 102. So we need to aim for about 102 participants if we're doing a one-tail test, meaning we're hypothesizing one group is going to perform or score higher than the other group. And this 102 essentially means we need 51 males and 51 females, or 51 people in your first group and 51 in your second group. And that would be ideal to run this t-test. If we change it to a two-tail test here instead of a one-tail, that sample size increases. So one-tailed tests are more liberal. We can see here with a two-tailed test, it's 128, which would mean you need 64 participants in both groups. Approximately, in a perfect world, that's what it would be. You're not going to have equal sample sizes all the time, but this is the ballpark to shoot for. So that's a t-test. We also have under the f-test family, you have ANOVAs and you have regression. So this is another big one, another test family that's commonly used. And say we're doing a linear regression. I'll select this option here. A regression is used when you're trying to predict an outcome. And a linear regression specifically is used when you have a continuous outcome. So for the power analysis on a regression, the same ideas apply. There is no one-tail, two-tail option. Everything's assumed to be two-tail here. So then you look at the effect size and you hover over. You can see it's a different value here. It's not a D, it's an F squared. So as I hover over this box, we can see what is the small, medium, and large effect size. Again, just go with the medium most of the time. If you don't have literature to say otherwise, your alpha is 0.05, power is 0.80. And then you identify how many predictor variables you have. So you could put 1 here. If we put 1 predictor, this is just the simple linear regression, 1 predictor variable. And we click calculate. The minimum sample to target for this regression would be 55 participants. Now you can increase that, and the more predictors you add, the larger your sample size requirement will be. Say I add 7 predictors to the equation. You can see the sample size has gone up considerably, almost double, to 103 participants. So try to keep the number of predictors low, I would say, in your methodology, or split up the research questions in a way that you have a low number of predictors in every equation. Otherwise, once you start really getting high into the predictor numbers, your sample size skyrockets. So we need 139 people for 15 predictors versus just a few, 3 to 4, you need 85 people. So this is something to think about, that you can kind of work backwards from your power analysis to determine your data collection procedures and determine whether it's feasible to gather enough participants. So that's G-Power. Here I have Intellectus, which is our company software, which is used for many things. It can be used to crunch numbers. It can be used to run power analyses. We also have data analysis plans in here. So for instance, we were just talking about a regression model. So this would go in your methodology chapter. You have your research questions, you have the independent and dependent variables, and then we have definitions of what a regression is, what assumptions you should check, and so forth. Under this menu here, we have power analyses. Okay, so we ran first a t-test for the difference between males and females. So like independent sample t-test. And you can see we provide a write-up. So this could essentially be copied and pasted right into your paper. What is the minimum sample I need with medium effect size? We calculated 128 participants, which would be about 64 each group. So this gives you, based on G-Power, Intellectus is using G-Power to replicate the findings and then putting it into an APA compliant document. We also did regressions. So if you take a look at linear regression, 1 participant or 1 predictor, you can see you change the number of predictors up here. If you have 1 predictor, ideally you need 55 people for a medium effect size. If you go with a large effect size, you can see how much smaller you need for the sample size, but you need literature to prove that a large effect size applies for your research. Likewise with the small effect size, going with the small effect size skyrockets the sample size up. So try to avoid that if possible. Okay, so if we change the number of predictors up here to 5, it's going to adjust the sample size calculation automatically. And you can download these documents at the top right here, and it'll put it into Microsoft Word. So that's Intellectus. Intellectus and G-Power are two good options today. So in summary, a power analysis is used to calculate the minimum sample size necessary for an analysis. And I should have specified here that this is for an a priori power analysis. We did discuss that there's a post hoc power analysis as well. And I can show you that in G-Power actually. So to do a post hoc again is done once you've collected your data and you've analyzed your numbers. You just change the type of power analysis here to post hoc. And you'll see what's changed is you're going to input your actual sample size that you obtained, and you're going to input the number of predictors that you obtained. And hopefully when you hit calculate, your power is above 0.8. Okay, so the more people you add, the higher that sample, or the higher your power is going to be as well. Okay, so that's how you do a post hoc power analysis. You first want to draft your research questions. Before you even start thinking about running the power analyses, you need to finalize your research questions and hypotheses, because you need to figure out what analysis you're going to use to address your questions. You need to identify how many independent and dependent variables you're examining, what is the effect size you're using, and what's the power level that's being used. Again, effect size, go with the medium unless you have literature, and power, just go with 0.8. And then you can calculate the minimum sample size for your research using G-Power or Intellectus. So I'll now open the webinar to questions if we have any. Again, let us know if you have any questions about your research. If you've hit a roadblock, you can contact us at 727-442-4290 or email us at info@statisticsolutions.com. And we can guide you in the right direction, provide specialists to help you with your paper, and efficiently get you through the dissertation. If we have any questions, I'll take a look now. Type them into the chat box. I do see Isaides has provided hyperlinks to the upcoming webinars that we're conducting. Okay, we have a question. Can you conduct mixed factorial ANOVAs in G-Power? Let's take a look. I believe you can. What you have to do is go to F-tests, and then you would be running most likely a repeat of measures within between interaction. So that means you have time, maybe a pre-test and post-test, and you also have groups. Okay, so once you go to this menu, let's go back to a priori, and you'll put your effect size, your power, the number of groups that you're comparing, you know, like male versus female or treatment versus control. And the number of measurements is going to be how many times you're recording the same data. Pre-test, post-test would just be 2 time points. Change the power to 0.8. Let's say we have a pre-test, post-test, number of measurements, and we have a treatment and control group. You click calculate. Looks like you need about 34 participants, which would mean 17 in your treatment and 17 in your control. And you can change these numbers as well. Maybe you have a baseline, pre-test, post-test, so 3 points in time. The sample size decreases with the more measurements you add. So the more time points you add, sample size will go. You're welcome. Yes, Michelle, we're going to send everyone a recording of this. You should receive it tomorrow. You'll receive a recording and a copy of the PowerPoint. All right, do we have any other questions? Any specific power analyses that you're trying to conduct and have hit a roadblock? I'll put someone's email in the chat box for you, Michelle, so you can email Janine. You can email Janine if you have any questions about support. Power analysis for surveys. So I did discuss, I went through some examples. So you're going to run a power analysis regardless of what data collection procedure you're using. So if you're using a survey, if you're using archival data, you're going to use a power analysis. Power analysis is contingent on what analysis you're proposing to address your research questions. So yes, if you're using surveys, then you most likely will need to do a power analysis. If you're doing tests like correlations, t-tests, regressions, ANOVAs, things like that, then you need to run a power analysis. Angela asked a really good question. So how many more subjects should you have on top of what the power analysis says in case of dropouts or data that isn't usable? I usually see, if anything, I'll see a 15 to 20% correction. So you do your power analysis, and to account for people dropping out potentially, or attrition, or people not completing the survey, add an extra 15 to 20%. What about a chi-square test? So I believe chi-square will be here. Under chi-square, goodness of fit contingency tables, again, changes to 0.8. Degrees of freedom, there's a formula for this. So say you're doing a relationship between ethnicity and gender. Okay, so I'll write this out. Kind of hard to explain without visualizing it. So chi-square is testing the relationship between two categorical variables. Say you have gender, which is male and female. You have ethnicity, is white, black, Asian, Hispanic. So you need to count how many groups you have in each. We have 2 groups here, and we have 4 groups here. Going off my memory, you'll want to double check this, but I believe what you do is you need to calculate the degrees of freedom here. So, and the way that's done is taking your groups in one variable and subtracting 1. EF is equal to 2 minus 1, 1. And then for this one, it's equal to EF equals 4 minus 1, 3. So for gender, you have 1 degree of freedom, and ethnicity, you have 3 degrees of freedom. You take those 2 values and you multiply them. So the final DF for chi-square is 1 times 3, which is 3. So that's what you would put in here. You would put 3 as your degrees of freedom, which yields a sample of 122 participants. Okay, I would double check that formula, but I'm almost certain it is doing subtraction and then multiplying the terms. Okay, do we have any other questions? I'll stay on for a few more minutes if we have any additional questions. And also check out our upcoming webinars here. See what we're conducting in the future. So it looks like the next one will be on Thursday next week, or Thursday tomorrow, I'm sorry, the 26th. So we have 2 webinars tomorrow. Okay, so mastering your discussion chapter and presenting quantitative results. Both good ones, discussing an entire chapter. And then next week, we'll be doing a chapter 1 webinar. And also on our company website, statisticsolutions.com, if you go to webinars, we just looked at the upcoming ones, but we also have a webinar archive. So you can see all the past videos that we've done. We've done these topics. We do 8 webinars a month. So come check out this page if you're not able to join a webinar, and you can watch the recording. All right, do we have any additional questions about power analyses, about the services that we can provide? Is there anything that you can do if you already collected your data but realized with the power analysis that it is less than 0.08? So you've collected your data already. Have you already crunched your numbers for the analysis that you proposed? Sounds like you might want to do a post hoc power analysis. So you take your given sample size, and then you identify the power of the test. So briefly touched on that, where say we're doing a t-test, and you change this option to post hoc. You identify your sample size, and then it tells you the achieved power. So that's what you can do after the fact. But there isn't really a way to manipulate it where if you have a low sample size, we can obtain a great power, unless your findings are extremely significant. You're welcome. All right, do we have any additional questions? All right, thanks for joining, everyone. Look out for the recording of the webinar, and come join us for the future webinars that we'll be doing, a couple tomorrow, and there's one next week as well. Let us know if you've hit a roadblock. You can reach out to that number I provided and discuss with Janine where you need assistance, and we can get you rolling in the right direction. Nice speaking with you all. Have a great rest of your day.